Hello people, welcome back. And in this session, we'll be trying to learn about the Central Limit Theorem or CLT. So some theory about the Central Limit Theorem is a fundamental concept in statistics that states the distribution of the sample average or sample mean approximate a normal distribution as the sample size gets bigger or gets larger, or you collect more and more sample. In case your data is not normally distributed, even that data will try to fit a normal distribution. How? I will tell you. So central limit theorem is often used in conjunction with the law of large sample or large numbers, which states that the average of the sample mean and the standard deviation will come closer to equaling the population mean and the standard deviation as the sample size will grow, which means as you increase the sample size, the average value of your sample data will be almost same as the average value of your population data. So the key component of central limit theorem are the sample size, which should be at least 30 or more than 30 samples you should be taken as per statistic, and the sample must be taken randomly and independently from the population. So randomly means data should pass the run test, or independently means data should pass the eye test or eye chart. So central limit theorem is useful when analyzing large data set because it allows one to assume that the sampling distribution of the mean will be normally distributed in most of the cases, which allows for the easier statistical analysis and the inference of the data. Central limit theorem have its own formula, but the formula is again depending on the what is the mean and the standard deviation of the data, or what is the standard error of the data. So central limit theorem is an important because it allows us to make inference about the population based on the sample, even if the population is not normally distributed. So how exactly the central limit theorem will work if we understand from an assumption like this is your one of the data. If you are collecting less number of data point, so probably the data point may be distributed like this. In this case, definitely you look at this data, the distribution of the data. If you look from the kurtosis point of view, the peak is too low. It's not a normally distributed. It's a platykurtic data. What I need, if I keep adding the data point into this, so basically the volume of the data will grow, and probably the variation will still remain in the control, because whenever we collect more and more data, maybe initially you will see the variation among the data point, but the later when the data point will be keep growing, it will try to follow a kind of normal distribution. And that's what exactly the principle of central limit theorem. As the data points grows and data points you collect more and more, it will try to fit in a normal distribution. So minimum sample size expected from any data analysis is 30, but you have the more than 30 data points, that's always helpful. Larger the data point, more confidently you will make your analysis and the prediction about the data. That's what the central limit theorem. Thank you so much, people. I'll see you in the next session.